we will study the linear programming problem with infeasible solution by graphical method. So this method it is used for two variable problem, and we'll see how the infeasibility of linear programming problem can be seen by this method. The given linear programming problem is maximize z equal to x1 plus 5x2 subject to the constraints 3x1 plus 4x2 greater than or equal to 240. This is the first constraint. And second constraint is 5x1 plus 3x2 less than or equal to 150. The second constraint. x1, x2 both are greater than or equal to 0. There are totally four constraints. First one is LHS greater than or equal to RHS. This is second one is LHS less than or equal to RHS, and two constraints x1 greater than or equal to 0, x2 also greater than or equal to 0. Totally four constraints we have. And the first step in solving the problem, as usual, as explained in our previous videos, the first step is to assume the constraints to be the equations. Now we write the same problem, maximize z equal to x1 plus 5x2. Constraints we write them as equations. 3x1 plus 4x2 equal to 240 and 5x1 plus 3x2 equal to 150. So x1, x2 are again greater than or equal to 0. Then we go to the second step, in which we put in the first constraint x1 equal to 0 and find the x2 value, that is 60. So in the first constraint, when we constraint equation here, when you put x1 equal to 0, x2 becomes 245, that is 60. And then put x2 equal to 0, then x1 is 80. So when x2 in the first constraint, when you put x2 equal to 0, x1 will be 240 divided by 3. So this is equal to 80. Second constraint equation is here 5x1 plus 3x2 equal to 150. Similarly, in this also we put x1 equal to 0, then x2 equal to 50, and put x2 equal to 0, then x1 is equal to 30. We get these values, and then in the step 3, what we do is we draw the straight lines on the graph representing the constraints 1 and 2 and identify the feasible region if there is a feasible region for the problem. So we go to the graph sheet as already explained in the previous video. So graph sheet, in the graph sheet we plot x1 on x-axis and x2 on y-axis, and in the first constraint we have, when we put x1 equal to 0, x2 is 60. I mark that point now. So when x1 is 0, x2 is 60. This is the intercept on y-axis. So first constraint, the intercept on y-axis I obtained here. And I go to second constraint when x2 equal to 0. First constraint, when I put x2 equal to 0, x1 equal to 80. I get second intercept which is on x-axis now. So x1 is 80. So x1 value I mark it at 80 and draw the straight line joining these two intercepts on x and y axis to get the constraint. So the constraint is shown by drawing the line joining these two intercepts which are on x and y axis. So this procedure already it is explained in our previous videos of C# tutorials, and the first constraint equation has been drawn by represented by a straight line on the graph. And now we go back to the original form of the constraint here, that 3x1 plus 4x2 first constraint is greater than or equal to 240. Now I mark the lines, the arrows, because it is constraint is given constraint is greater than or equal to 0. I mark the arrows away from the origin. I show the arrows away from the origin. So like this constraint shows the direction away from the origin. First constraint, show the arrows away from the origin because of greater than or equal to sign in the given constraint. This is the first one. Mark the first constraint. Then go to second constraint. When we put x1 equal to 0, x2 is 50. I mark that point on intercept on y-axis. When x1 is 0, x2 is 50. It is here. I am marking that. So when x1 is 0, x2 is 50. Mark the point. And when x2 is 0, x1 is 30. So second point, the intercept on x-axis, I am marking now. This is when x2 is 0, x1 is 30. Join these two intercepts. Draw the second constraint. Represent the second constraint by straight line on the graph. This way. So now I have drawn the straight line representing the second constraint on the graph, and go back to the original form of the constraint and see that LHS is less than or equal to RHS, that is 150. So less than, when it is less than, we show the arrows towards the origin, this way. So show the arrows towards the origin. So now when you observe these two constraints, first constraint shows above the origin, and second constraint is showing below the above this line, and second constraint is showing the arrows towards the origin. And now we can see that there is no region on the graph which is bound by these two constraints, because one is showing away from the origin and another is showing towards the origin, and there is no feasible region in this case. For this problem, there is no feasible region on the graph, and we cannot take the negative sides of the x and y axis, because the another constraint we have that x1 x2 must be either 0 or positive. So only on the positive side of the graph we have to see, and we observe here that there is no feasible region, and hence this problem does not have a feasible solution. So now we just write no feasible region, for the problem, and hence the problem has infeasible solution. So this is how we have to identify whether the problem has a feasible solution or an infeasible solution. The infeasible solution means there is no unique solution to the problem which satisfies both the constraints. See, the solution actually, what we obtain for this problem, the values of x1, x2, they should satisfy both the constraints, both of these constraints. Then only we call that solution as feasible solution. Because there is no feasible region in this problem, as we have observed, we write that there is no feasible region for the problem, and hence the problem does not have a feasible solution, it has infeasible solution. So we do take this conclusion and stop the solution procedure here. Thank you.